With human health and disease, there are non-communicable diseases and communicable diseases. And we're going to look at several here. Most of these involve animals, some of them involve plants. HIV, the human immunodeficiency virus, leads to AIDS, but AIDS is quite separate from HIV, as I'll explain later. So it is a virus that can be passed on, transmitted through sexual contact, whether it's homosexuality or heterosexuality. It can also be passed on from mother to child, quite rare during pregnancy, but more likely during the process of childbirth or even breastfeeding. But if a baby is born by C-section, cesarean section, then the chance of transmission that way is reduced, and if the baby is bottle fed rather than breastfed, again, no chance of passing HIV on that way. It can also be passed on from needle stick injuries or sharing needles, such as intravenous drug users. What HIV does is it infects several types of cell in the human body, but one type of cell it infects, which leads to the onset of AIDS, are lymphocytes, in particular T helper lymphocytes. These type of lymphocytes, which are white blood cells, coordinate an immune response. So if the virus infects these cells and starts destroying these cells, then the person's immune system is going to be much weaker, and that leaves them more susceptible to infections. And when they are more susceptible to infections, they then suffer from AIDS, acquired immuno or immune deficiency syndrome. Now, there are numerous symptoms of this. Syndrome means a range of different symptoms. One such symptom is that they may suffer from other diseases, opportunistic diseases. These are diseases that take advantage of a weakened immune system. One such disease is tuberculosis or TB. Now, many people have a latent form of TB that's inactive, and if their immune system is weak, then they start suffering from TB more. The same with pneumonia. Pneumonia is a disease common with people with weak immune systems, the young or the elderly. But if you're immunocompromised, if you're suffering from AIDS, then pneumonia can be quite deadly to you. There is also a range of many other symptoms as well, which are listed here. How we can prevent or treat HIV, or if you have AIDS, are by the following ways. Prevention is always the best, and if it's transmitted through sexual intercourse, the best prevention there is to use a barrier contraceptive such as a condom. That will help to stop transmission of the HIV from man to woman and woman to man, or man to man. If you're going to be dealing with blood, then various protections such as gloves. So first aiders may carry gloves with them. And if you have got HIV, then a range of drugs are available called antivirals, and these help to stop the virus replicating inside the cells, and they're pretty effective these days. And many media reports claim that HIV patients can live a long, healthy life without ever developing AIDS. There are now drugs even that people can take to prevent infection of HIV. People, if they think that their lifestyles make them more vulnerable or susceptible to getting HIV, can take these drugs to prevent them becoming infected. Chlamydia. Chlamydia is an STI, sexually transmitted infection, very, very common, and it's caused by a bacterium with Chlamydia trachomatis. That's good news that it's caused by bacterium, as I'll explain shortly. Chlamydia is passed through sexual contact, as the diagrams here indicate the various ways that can happen. Now, if you suffer from chlamydia, it's going to infect, if you're a female, your ovaries. It can affect your fallopian tubes. It can cause inflammation, and you may or may not feel this. It can be symptomless, which is a bit of a problem because then a female might not know that she's infected and therefore doesn't do anything about getting treated for it. Males, on the other hand, are probably going to realise this. They're going to have a painful penis. But again, the symptoms may come and go. So once the symptoms are gone, a male may not actually go and get treated and hope that nothing is wrong anymore. But if either the male or the female have a hope of getting children, it could become a problem because chlamydia can cause infertility. It can also cause conjunctivitis in babies as they're being born down the birth canal. if a woman is infected with chlamydia. How can we prevent it? Well, it's an STI, so again, condoms would be very good here, barrier contraception, and because it's bacteria, it is treatable with antibiotics. But we have to be careful these days not to overuse antibiotics. We do not want to develop by natural selection antibiotic resistant chlamydia, because that will make it much harder to treat in future. TB, tuberculosis. It's also caused by bacteria, Mycobacterium tuberculosis. That means, of course, it can be treated with antibiotics, as I'll explain later. So how it actually spreads is by droplet infection. So if somebody sneezes or coughs and they're infected with TB, those bacteria in little droplets can be inhaled by the other person into their lungs. Droplet infection. It can also be done by people when they're speaking in close contact and little droplets come out of their mouths. So what happens then? Well, most people who've got TB have got latent TB. That means they're infected, but it's not causing them any problems and they're not infectious either. But some people will develop active TB. This is where it's starting to become a problem for them. It's going to cause them illness and they can become infective by droplet infection. And one of the symptoms though is extreme tiredness. There's also many other symptoms that you can see listed here, and I think the most profound one there is going to be the coughing of blood, and I think if anybody starts coughing up blood you should seek medical attention anyway. Now, it's a big disease. Many people around the world are infected. Many people die. I think this diagram is a little bit misleading. You've got a big circle saying the world population of 7.5 billion, and you've got still quite a big circle, 1.8 million deaths per year, but proportionally this is not representational. That circle, 1.8 million deaths per year, should be much smaller. Nonetheless, 1.8 million deaths per year is still significant. So what can we do to prevent it? Well, basically TB is spread by overcrowded conditions. So this does affect poor countries, poor people in the world, and also those who are malnourished. If you're got good nourishment, your immune system is healthy, you can keep TB in its latent form. If you're not living in overcrowded conditions, you're less likely to inhale these droplets containing the bacteria. So good open spaces, not crowded conditions, good nutrition helps to prevent TB. There was also a vaccine for it called the BCG. It used to be offered in the UK but not anymore. The problem with it, it's only effective in the young people, so you have to have it whilst you're young, and only effective in 70% of the cases. So cost effectiveness of it is in question. If you do suffer from it, particularly the active form, or if you just discovered that you've still got it with a latent form, a course of antibiotics should get rid of it, but the course of antibiotics lasts a long time, perhaps about 9 to 12 months. And these days they often give you more than one type of antibiotic to try to prevent natural selection of antibiotic resistant TB, which is becoming a problem. Cholera, also caused by bacterium Vibrio cholerae. Now, this can get passed on in contaminated drinking water. Contaminated drinking water where the sanitation is poor and fecal matter has managed to enter the drinking water, which can happen in many parts of the world, particularly disaster areas. It can also be contracted by eating shellfish. These are filter feeders, so they filter the water, and if they're living in water that's contaminated by fecal matter, they will pick up the cholera pathogen. And if the food hasn't been cooked properly, or any food that has been actually washed in this water hasn't been cooked properly, then it will get passed on to the person. And word of warning, it can also be an ice cube. So you could be in a hot country, a tropical country, a poor country where cholera is endemic. You're having a drink what you think is safe. It may have come out of a can, a tin of Coke. You put ice in it, but if the ice has been made with water that has come from a source where there's poor sanitation, you may well contract cholera by that way. Well, it causes diarrhea. It causes diarrhea because the bacteria releases a toxin. Toxins are usually one of the ways that most bacteria are going to make you feel ill. Now, if you study this diagram, you can ignore most of it for GCSE level, but if you can focus on the top right hand side where it says lumen of small intestine, you can see that there's chloride and sodium ions which are leaving the intestinal cells into the lumen of the intestine. Now, if you remember your biology, if you have a high concentration of salts in one area, that will lower the concentration of water. And in this case, you get a high concentration of water inside the cells, a low concentration of water inside the intestine, and then water is going to leave those cells by osmosis. As a consequence of this, you're going to get diarrhea and severe dehydration. Say no more. So how can we prevent or treat this? Well, don't forget it's in contaminated water where there's poor sanitation, so provide clean water and no more cholera. Food should be cooked properly if you're unsure about what water it's cooked in, particularly seafood. If you do suffer from cholera, then if you can replace some of those salts, you're going to decrease that water concentration gradient and therefore lose less water. So this can be a lifesaver. You can either make it yourself, follow the method that you can see now, or you can buy packets of oral rehydration salts, and these are lifesavers. Antibiotics can be used, but it depends how quickly you catch the infection, and there is also a vaccine for it. But vaccines are expensive to administer to the population, and also, as you can see in this picture, they have to be stored at 2 to 8 degrees Celsius, and in some poor countries there is no ability to store vaccines at that temperature. Ultimately, good sanitation is the best method. Malaria. This is not caused by bacteria, neither is it caused by a virus. This is caused by a protoctist of a type called Plasmodium. And you can see a picture of a Plasmodium just beneath the second A in the word malarial. It's infected a red blood cell there. And that's generally what they do. How do we get it? Well, you can't pass it from person to person. You need something called a vector. A vector transmits the disease from one organism to another. And in this case, the vector is one particular type of mosquito, one species of mosquito called Anopheles. And even then, it's only the female of the species that will do that, not the males. The females have to get protein to lay their eggs, and so they get this from the blood that they consume. So if a mosquito takes a blood meal from an infected person, the blue person here, and then they again take a second blood meal. So that's taking a second blood meal, this time from an uninfected person. They can then transmit the malarial parasite, the Plasmodium. What it does? Well, it infects liver cells, but before it gets to that stage of infecting liver cells, it will infect a lot of red blood cells. And when it infects those red blood cells, it destroys them and makes the person anemic. Anemia is where you get a loss of red blood cells, and blood cells carry oxygen, and if you're not carrying a lot of oxygen around, you are going to feel very, very tired. So it's a very debilitating disease, and it can cause mass economic problems in the countries because people are so tired they can't work. And it can cause many other symptoms as well, and in some cases leading to death. How we can prevent malaria? Numerous ways. The drive is to make a vaccine against it. Not entirely successful at the moment, but there's a lot of work going into it. Failing that, try to prevent it in the first place by taking prophylactic drugs such as paludrine. So if you're travelling to a malaria endemic country, you'll take these drugs before you go, whilst you're there, and for a certain period of time when you return. So it doesn't stop you getting infected with the parasite, but it will help to stop the parasite from establishing itself. Prevention can also be carried out by using mosquito nets and covering your body up in nighttime hours when the mosquito tends to be feeding. You can use repellents to help with this. some countries would be able to spray insecticides to reduce the number of mosquitoes, but of course there is a problem here. This is a pesticide, an insecticide, and so it could be killing other insects that may be useful. So you have to be careful when you use insecticides. If we are trying to target the female Anopheles mosquito, but other insects could suffer. Biological controls. Now this biological control means you're using another organism to help reduce the numbers of another species, and in this case fish can eat the larvae of mosquito. So you have to know about the life cycle of the mosquito there, and part of the life cycle is that they lay their eggs in water, the eggs develop into larvae, and if there's fish there they can eat the larvae and they're not going to grow up to become adult mosquitoes. And quite a clever way of doing this is that we can release infertile male Anopheles mosquitoes into the wild. They will mate with the females, and once the females are mated they won't mate again, and because they've mated they won't have fertilized eggs, and therefore they won't lay any more eggs, and that will reduce the number of mosquitoes. This has got some success, but it has to keep being repeated, and that of course has a cost. Stomach ulcers. Now previously, or not many years ago, people thought stomach ulcers were just a bit of bad luck, too much acid being produced, and you'd have to take drugs, possibly for many years of life, maybe even an operation to help cure them. And then in the mid-1980s, a couple of Australian scientists discovered that most stomach ulcers are actually caused by bacteria. In this particular instance, Helicobacter pylori. Helicobacter pylori infects the stomach and the duodenum, which is part of the small intestine. And it's a unique bacteria here because it can withstand the very low pH of the stomach. How we get it? Well, it's in the stomach, it's in the intestine, so poor hygiene can spread it. So fecal to oral contact, in terms of if somebody has gone to the toilet, haven't washed their hands properly, start handling food, and somebody else needs their food, they can transmit the bacteria. So particularly common in people who live together, crowded conditions, family members, anywhere where you've got poor sanitation. So what it does infect the small intestine and the stomach, and it disrupts the membranes of the cells lining the intestines, particularly those cells that start to release mucus, which protects the lining of the stomach from the acid. So as a result of that, the hydrochloric acid starts to damage the lining of the stomach, and you get very painful ulcers. So extreme pain here, but there are a range of other symptoms as you can see listed here. To prevent it, good hygiene. Make sure you wash your hands before cooking food, or wear protective gloves as you're preparing food. Make sure that the water is clean, so good sanitation or bottled water would help. It is a bacteria, so a range of antibiotics will help to cure you if it turns out that you're infected with this bacteria. I should go to say that if you have got this bacteria, it does not mean that it will lead to stomach ulcers, but it looks like stomach ulcers are mostly caused by this bacteria. On to another virus, Ebola. Often in the news. Often in the news because what it does to people seems quite severe. It can be spread by person to person. Any form of contact can spread it. It can be spread by eating animals that are infected, which we often call bushmeat. You might actually eat some food that's already had a nibble from another animal. Anything involved poor hygiene in medical areas can pass this on. And its symptoms are pretty horrendous. It can cause something called hemorrhagic fever. Hemorrhagic fever is as a result of blood clots forming. And you can see the results of these blood clots forming in this picture here. As well as blood clots forming, it can also cause blood vessels to start leaking blood. So the victims start having a lot of internal bleeding, hemorrhaging, and therefore suffer loss of blood. And there's a number of other symptoms associated with this as well over the course of 12 days, as you can see in this image here, ranging from headaches to seizures and death. Treatment for it? Well, there's not much. First of all, you have to be isolated to prevent you spreading it to somebody else. And then it's a case of keeping your body fluids up, so you can have a drip of electrolytes. You might have to have an oxygen supply because you've lost a lot of red blood cells, so you're not carrying a lot of oxygen around your body, and blood transfusions may well help to keep you alive until your immune system can hopefully deal with the Ebola virus. And now we move on to a one and only plant disease we need to look at. This one is called ash dieback. It infects a tree called the ash tree, and it's caused by a fungus. So this is the only disease that we're looking at which is a fungus this time, and it's a fungus called the Cholera fungus. Now fungi reproduce by producing spores, and these spores, to spread around, are just carried by the wind. So they will go from tree to tree, carried in the air. So these are airborne spores. And why is that a problem? How does a fungus affect a tree? Well, the Cholera fungus will affect the ash tree by causing leaves to die or bark lesions. But before we do that, let's just talk a bit more about the airborne spores. We can see on the picture of the UK here that there's a high concentration of ash dieback in the southeast and East Anglia, and considering that most of our prevailing winds are usually southeasterly winds, most of the spores are carried across the country to the eastern side. And when they do infect a tree, they cause lesions in bark, but most obvious in the disease is that you get wilting and browning of the leaves. And the reason why it's called ash dieback is that the top of the leaves, the top of the tree is called the crown, loses its leaves, and that's why it's called ash dieback. So what can we do? Well, if you've got a tree that's infected with cholera, one method of prevention is to stop moving the logs around the country. So if you fell the tree and log it, don't use the wood for anything. The other prevention is to actually just cut the trees down as they get infected, and hopefully that will stop the spread of disease. But some people disagree that this is the best way to manage it. And the reason for this is that if the trees are left standing, then because of genetic variation, there will be the natural selection of trees that may well be resistant to the fungus. But if we keep cutting them down, that is not going to happen. So there's two schools of thought there. Do we cut them down or do we leave them?